Hello, Assalamualaikum and very good morning. So today, my group will present the application of heat transfer in our daily life and in industry. So before we moving forward to our explanation, and we would like to introduce ourselves. So first, my name is Muhammad Arif Hakimi bin Muhammad Yusri. My metric number is 193473. Safwan.
My name is Muhammad Safwan bin Anuari and my matrix number is 192074.
Okay, hi, my name is Muhammad Asyraf bin Ahmad Sukri. My matrix number is 192216.
Before we move for the detailed explanation, I would love to make a summary of our video. So firstly, Safwan will explain the the application of heat transfer in our daily life, in our surrounding. Next, me myself, I will explain the application of heat transfer in industry. And Asyraf will explain the calculation that involve heat transfer. So I would like to pass explanation to Safwan.
Okay, thank you, Arif Hakimi. So for the daily use, daily application for heat transfer in our group, so we choose cooking application. Okay, so for the cooking, it consists 3 ways heat transfer mechanism during cooking, which is first, secondly is convection, thirdly is radiation. So I will explain each of these ways during how the mechanism of the heat transfer. So for the conduction, as we know that heat transfer is due to contact of a molecule. So the conduction is the process of heat being transferred between objects. How to write it? Okay. Okay, for example, like this one. Okay, this cooking burners will conduct heat energy oh my god, to the bottom of a pan sitting on top of it. So from there, the pan conducts heat. This pan will conduct heat and conduct heat lah. Conduct heat. Conduct heat. 2 is content. This one like this one, like we want to boil the water, so like it's a particle of the water. Okay. So we're moving on to the conduction, to the convection. So for the convection, it is a heat transfer due to contact of molecule, which means that for example, when we heat this burger, so the conduction will make the conduction will make the burger, this burger, nearer the heat source, Yeah, the heat source, which is this one, heat source, the fire, and then okay, so when the heat source, when the burger is nearer to the heat source, so So the conduction will heat up the pot, which then hits the burger molecules inside the burger molecules inside it lah. So as this molecule hits, convection causes them to move away from the interior of the pot as they're replaced by cooler molecules. So this continuous current creates convection heat transfer within the burger. So for the third mechanism, which is the radiation, as you know, radiation is a heat transfer due to energy wave emitted by another object. This one. So for the radiation, they involve a source of electromagnetic radiation that beams energy to food. Electromagnetic. Okay. So this particle instead are absorbed sometimes by the food. So each part of the food, in the fact, has its own characteristic way of interacting with the radiation, known as absorbent. So when food absorb radiation, the energy of the radiation particle is converted to heat. So as a summary for the how the heat transfers in cooking. So from the conduction, the heat from the stove we transfer to the pan via conduction. Secondly, the heat is transferred through the food via convection, and then lastly the element transfer heat to the kitchen via radiation. So the element which is the food, we transfer the heat to the kitchen via radiation. So it's basically is a mechanism for the heat transfer during cooking. For the thermal properties of cooking media, as you know, the high conductivity, high K, is the best conductor of material. So which high K will make the heat transfer rate become faster. So which is that when you want to cook something like you want to cook fried chicken, so we have to choose a frying pan that high conductivity, such as materials such as copper, aluminium, because and steel, because it's the best conductors of heat. So that is the overall mechanism on the application of heat transfer in cooking. So that is all from my part. So I will pass to Arif Hakimi to continue the presentation. Thank you.
So let's move on to the application of heat transfer in industry. As we all know, nuclear reactor is one of the kind of power generation, electric power generation that involve a very high pressure, a very high temperature in order to spin the turbine, which then is the kinetic energy that comes from the turbine is converted into electrical energy. So how does these things work? So when the turbine is spinning after the involvement of pressure, high pressure and high temperature, the hot water will pass into the cooling tower, which then is converted in the hot water is then converted into cool water at the cooling tower. So I will explain where is the heat transfer involved in this cooling tower. So basically, the most heat transfer that involved in cooling tower is convection. So how does this thing work? Okay. So when the hot water coming into the cooling tower,
Arif,
so
Arif, why your screen share is black and white only?
okay, sorry for the distraction. So I will start it again. So when the hot water moving into the cooling tower, the hot water basically will spray out like this, spray out to basically to increase the contact area with the air, so that there will more heat transfer between the air and the water, and then by when the water moving down to the reservoir, the water is losing its heat. So when it's reached at the bottom level of the cooling tower, the air should be lower temperature than before. So that's how the cooling tower works. So I will pass the next explanation to Asyraf. Asyraf, I will pass the host to you. Wait a moment.
Okay. All right. Okay. Now we proceed to the calculation. So like previously that Arif Hakimi said that this is the reactor. So this is a diagram that I draw, which is a reactor for the industry. So which is the air inlet with the water inlet. This is a water inlet. So water can move through the reactor, then the water drop and have a convection with the air. So then the drop water will be cold. So now, based on this diagram, we want to find the heat flux. So the given information is the temperature inlet, which is here, is 40 degrees Celsius, and the temperature infinity, which is the outside is 20 degrees Celsius. So we can find the heat flux. So then the formula for heat flux is the H multiplied with the T inlet minus T infinity. So the H how can we find the H? So H is refer to the table A4. Sorry. So the table 1.1, which is the table of the heat transfer heat convection coefficient, which is we can find the H for the gases fluid in free convection, forced convection. Then for our group, we assume that the value H is 20 watt meter squared K. So per meter square K. So we put the information into the equation. So 20 is for the H value. So we put the temperature of inlet and infinity. So then we calculate, then we got the heat flux for this reactor is 400 watt per meter square. I think that's all from me for the calculation. No?
Okay. Okay. So I think we made good explanation for this assignment. I hope we learned something based on this assignment. So thank you for your commitment. See you guys later.
Okay, see you guys. Thank you.
Thank you.
Thank you.